Lesson 5, using identity and inverse to write equivalent expressions. Module 3 continues. In our opening exercise, in the morning, Harrison checked the temperature outside to find that it was negative 12 degrees Fahrenheit. Later in the afternoon, the temperature rose 12 degrees Fahrenheit. Write an expression representing the temperature change. What was the afternoon temperature? If we were to write an expression for this, we would obtain the following. Negative 12 plus 12. So the afternoon temperature was 0 degrees Fahrenheit. For number 2, rewrite subtraction as adding the inverse for the following problems and find the sum. Part A. We have 2 minus 2. We rewrite 2 plus negative 2. The sum is 0. Part B. Negative 4 minus a negative 4. We rewrite and we find that the sum is 0. Part C. The difference of 5 and 5. 5 plus negative 5, the sum is 0. Part D. G minus G is the same as G plus a negative G. The sum is 0. Part 3. What patterns do you notice in opening exercises 1 and 2? We see that the sum of a number and its additive inverse equals 0. Part 4. Add or subtract. Part A. We have 16 plus 0. Our answer is 16. Part B, we have 0 minus 7. Our answer is negative 7. Part C, we have negative 4 plus 0. We get negative 4. Part D, we have 0 plus D. Our answer is D. Part E, what pattern do we see here? What is happening in parts A through D? The sum of any quantity in 0 is equal to the value of the quantity. 5. Your younger sibling runs up to you and excitedly exclaims, I am thinking of a number. If I add it to the number 2 10 times, that is 2 plus my number, plus my number, plus my number, so on, then my answer is 2. What is my number? You almost immediately answer 0, but are you sure? Can you find a different number other than 0 that has the same property? If not, can you justify that your answer is the only correct answer? There is no other number. The only answer possible here is 0. Adding any other number to 2, we would get a different answer other than 2. So our number must be 0. Example 1. Write the sum and then write an equivalent expression by collecting like terms and removing parentheses. Part A. 2x and negative 2x plus 3. We want to find the sum, so we want to add these two quantities together, like so. The 2x and the negative 2x cancel out. Our sum is 3. Part B. We want to find the sum, 2x minus 7 and the opposite of 2x. This is how it would be written. 2x minus 7 plus negative 2x. Rewrite by reordering using the commutative property of addition. 2x plus negative 2x minus 7 Our sum is negative 7. Why is this? Why is our sum negative 7? Because 2x plus a negative 2x is 0. And 0 minus 7 is negative 7. Part C. The opposite of the quantity 5x minus 1 and 5x. We first write it out. Negative quantity 5x minus 1 plus 5x. We rewrite again. By distributing that negative through, we get negative 5x plus 1 plus 5x. Reorder using the commutative property of addition. Negative 5x plus a 1. Negative 5x and 5x become 0. They cancel each other out. So the sum is 1. Let us go to exercise 1. We're going to write the sum, then write an equivalent expression. Our goal is to simplify. Part A, negative 4 and 4b plus 4. We rewrite using addition. We have negative 4 plus the quantity 4b plus 4. The negative 4 and the positive 4 will cancel out. Our final answer is 4b. Part B, we have 3x and 1 minus 3x. We write it. We have 3x plus the quantity 1 minus 3x. 3x minus 3x is 0. So our final sum is 1. For part C, we have the opposite of 4x added to negative 5 plus 4x. This is how it would be written. The negative 4x and the positive 4x cancel out to get 0. Our final answer is negative 5. Part D, the opposite of negative 10t and t minus 10t. We have negative 10t plus t minus 10t. The 10t's cancel out. We are left with one single t. Part E, the opposite of negative 7 minus 4b and negative 4b. We write it out. Negative quantity, negative 7 minus 4b and quantity, plus negative 4b. The 4b's cancel out. We are left with a positive 7 as our final answer. 2. Simplify each product. The hint that I am giving you in parentheses here is we are multiplying reciprocals in this section. 3/4 times 4/3. We could write it in multiple ways. We could do the following by multiplying numerators, multiplying denominators. 3 times 4 all over 4 times 3. It's the same thing. The numerator and denominator are the same. They cancel out. We get 1. The 3's cancel out. The 4's cancel out. Our final result is 1 for this product. For the second one, we have 4 times 1/4. There are 2 ways we could look at this. We can multiply 4 times the numerator and have 4 times 1 all divided by 4, which results in 4 over 4, which equals 1. Or, since it's 4 times 1/4, the whole number that we are multiplying to this fraction is the same as the denominator. They cancel out. And we have a result of 1. The next one, we have 1/9 times 9. The same can go here as well. The 9's cancel out. We are left with 1. For the next one, negative 1/3 times negative 3. The denominator and the integer 3, negative 3, will cancel out. We have a negative times a negative. Our answer is positive 1. Here we have negative 6/5 times negative 5/6. The 5s and the 6s will cancel out. And our result is a positive 1. For our next example, write the product and then write the expression in standard form by removing parentheses and combining like terms. Justify each step. Part A, the multiplicative inverse of 1/5 and the quantity 2x minus 1/5. The multiplicative inverse of 1/5 is 5. We are taking 5 and multiplying it to the quantity 2x minus 1/5. We then distribute the 5 to both terms inside those parentheses. We then simplify and have a result of 10x minus 1. And we can verify this using a calculator. Part B, the multiplicative inverse of 2 and 2x plus 4. The multiplicative inverse of 2 is 1/2. 1/2 times the quantity 2x plus 4. We distribute the 1/2 through. 1/2 times 2x plus 1/2 times 4. We simplify and we get a final answer of x plus 2. For part C, the multiplicative inverse of 1 over the quantity 3x plus 5 and 1/3. We write it out. The multiplicative inverse of 1 over 3x plus 5 is 3x plus 5. We simply flip the fraction. We are now multiplying 3x plus 5 times 1/3. We distribute through. 1/3 gets multiplied to everything inside those parentheses. It gets multiplied to the 3x. It gets multiplied to the 5. And now we simplify. 3 times 1/3 is 1. 5 times 1/3 is 5/3. Our final result is x plus 5/3. Moving on to exercise 2. Doing the very same concept we were doing in the previous example. For part A, the reciprocal of 3 and negative 6y minus 3x. We write it out. The reciprocal of 3 is 1/3. We're multiplying 1/3 to negative 6y plus a negative 3x. We distribute through. Multiply that 1/3 to both terms inside the parentheses. We simplify. And we get a final answer of negative 2y minus x. Part B, the multiplicative inverse of 4 and 4h minus 20. The multiplicative inverse of 4 is 1/4. 1/4 times 4h minus 20. We distribute the 1/4 through. 1/4 times 4h. 1/4 times negative 20. We simplify our answer. And we get h minus 5. We go on to part C, the multiplicative inverse of negative 1/6 and the quantity 2 minus 1/6j. The multiplicative inverse of negative 1/6 is negative 6. So we have a negative 6 times the quantity 2 plus negative 1/6j. We distribute that negative 6 through. Negative 6 times 2 plus a negative 6 times negative 1 over 6j. We begin to simplify. Negative 6 times 2 is negative 12. Negative 6 times a negative 1/6 becomes a positive 1. now have negative. For our conclusion today of lesson 5, we have the following summary questions that in class. The questions are these. What is the reciprocal of 1/5? Our second question. If you multiply any number by its reciprocal, what will the result always be? What will the result always be? And finally, what is the sum of a number and its opposite? This concludes